Looking at our phase changes exit ticket here, you got to revisit a diagram, an image that you saw in your pre-quiz, but that you did not see during the lesson. And there's good reason for that. The container and the direction of the arrows and the color of the arrows don't matter. All that matters is that you understand what these little particles represent and how they become an interchange between the different phases. So this question specifically asks about attractive forces, but in the lesson we discussed how many concepts come together to help us understand phase change. One, attractive forces between particles in states of matter. We talked about them being tight together in solids and loosey-goosey in gases. Liquids are somewhere in between. We also talked about, so not just the space between molecules, the attractive forces, but also the speed of the particles, which is not something you can see here, but something you can imagine and something you've been able to see in simulations. Gas particles move very fast, solid particles move very slow, and liquid particles move somewhere in between. This also requires us to understand what happens when we change temperature. We have an intuitive knowing at this point in our life that we have to heat a solid to get it to melt to a liquid. So we are increasing the temperature of the particles, which we learned in our temperature lesson means we're increasing the speed of the particles. By increasing the speed of the particles, we get some more space between the particles. And so it doesn't matter any configuration of images, it just matters that you know those facts. This question in particular asks you which of these numbered processes is characterized by increasing attractive forces between the particles of matter. So we look and we go, well, a solid has the most attractive forces among any phase of matter at all. So anything becoming a solid is going to be increasing the attractive forces. Here, number 2 is a gas becoming a solid. We had no attractive forces. Here we have strong attractive forces, so definitely 2. If we look at the other arrow pointing to the solid, we go 6. 6 goes from a liquid, sort of floating around loosey particles, to very strict and rigid particles. Lots of attraction there as well. And now we know gases have virtually no attractive forces between them because they just love to escape and get away from each other. So not going to focus on that phase of matter much at all, but we know liquids do have some degree of attractive forces, which is holding them in the container in a defined volume. We don't change, the volume doesn't change easily. So looking at the arrows that point to the liquid, we can see number 4 points to the liquid here. We go from a gas with very few attractive forces to a liquid with lots of attractive forces. So 4 qualifies as well. And the only other arrow pointing to the liquid is number 3, which comes from a solid. Now the solid clearly has lots of attractive forces and the liquid doesn't have as much. So in number 3, we're actually looking at a decrease in attractive forces, a loosening of the particles during that phase change. So 3 would not qualify there, and 5 and 1 are precluded by the fact that they make a substance with virtually no attractive forces. So gas to solid, we reviewed this is called deposition or depositing as a phase change name. 4 is gas to liquid, that's condensing or condensation. And 6 is liquid to solid, what you know and probably have known for a long time as freezing.